A river of breadth A with parallel straight banks flow with uniform velocity u. In the figure, the points A, B, C and D lying on the banks are the vertices of a square. Even diagram. Two boats B1 and B2 moving with constant speed V, here V greater than U, relative to water, begin their journey at the same instant from A. The boat B1 first travels to C along AC and then D in the direction C to D upwards along the river. The boat B2 first travels to B in the direction A to B downwards along the river and then to D along BD direction. Sketch the velocity triangles for the motions of B1 from A to C and of B2 from B to D in the same diagram. Hence, show that the speed of the boat B1 in its motion from A to C is 1 over root 2 within bracket square root of 2b squared minus u squared plus u. Find the speed of the boat B2 in its motion from B to D. Show that both boats B1 and B2 reach D at the same instant. Answer for this question. This is one of the river. Breadth A is velocity u. 4 points A, B, C and D, vertices of a square. These are the diagonals. Therefore, this is 45 degree. Now, two boats start from A, B1 and B2. Just observe the motion. These are the motion. But the final part of the question, we want to show that two boats reach point D at the same time. Let the boat B1 and B2, B1 travels along A to C, then C to D, B2 travels along A to B, then B to D. Let river R, earth E. Velocity of river relative to earth, BRE, that is given is u. Velocity of B1 relative to R is equal velocity of B2 relative to R is equal V. It is given. Consider the motion of the boat B1. Boat B1, that is a red color boat. Consider the motion. From A to C, it moves with the velocity R1, let velocity R1. Then C to D, it moves with velocity R2. is relative to Earth. Velocity of B1 relative to Earth is in this direction R1, then in this direction R2. This one, have a look. Both B1 from A to C, R1 velocity, from C to D, R2. Theory of relativity, velocity of B1E is equal velocity of B1R plus velocity of RE. This one, B1E, true velocity from A to C is R1, then C to D is R2, is equal velocity of B1 relative to R. This is a V. V given B plus BRE. Velocity of river relative to Earth is a U. Now we want to draw the velocity triangle for the motion of boat B1. Start from U, velocity U, then plus B, we don't know the directions of V. Therefore, we draw one of the circle with the radius V. V might be anywhere in this circle. We know the magnitude of V, but we don't know the direction. And also we are given V greater than U. Therefore, this radius of the circle is greater than U. V might be in any direction. Okay, according to this theory, R1 is the R1. First, we want to complete one of the velocity triangle. The resultant is R1. Therefore, in this U, R1 in this direction, it's horizontal 45 degrees. Therefore, V might be here. Now, complete the velocity triangle. U, then V in this direction, resultant R1. Therefore, this is the first velocity triangle. U plus V, this is R1. And also, one more resultant is R2. Therefore, we want to complete one more velocity triangle. U, horizontal direction, and B, we don't know the direction, but the resultant R2 in this direction. Resultant R2 in this direction. Therefore, B might be here in this direction. U, then V like here, then R2 in this direction. Now we want to find out the magnitude of R1. This is R1. How to find out the R1? Draw one of the perpendicular from A to this OC, that is AM. This AM is equal U sine 45. This is a right angle triangle. Therefore, AM is equal U over root 2. And OM, this is OM, U cos 45. Therefore, OM also U over root 2. This is AM U over root 2, OM also U over root 2. Using Pythagoras theorem at triangle AMC, in this yellow color triangle, we want to use the Pythagoras theorem. MC is equal square root of B squared minus AM squared. But we know the AM u over root 2 or u sine 45. This is equal B squared minus u over root 2 all things squared, that is u squared by 2. MC is equal, when we simplify further, 2v squared minus u squared over square root of 2. But R1, this is the R1 is equal OM plus MC. This is R1. OM plus MC. For this OM, we can put u over root 2 plus MC here. MC square root of 2v squared minus u squared over root 2. When we simplify further, R1 is equal 1 over root 2 within brackets 2v squared minus u squared square root of 2v squared minus u squared plus u. This is the R1. Next part, consider the motion of the boat B2. Okay. Now consider the motion of the boat B2. Boat B2, this one green color, moves from A to B. Boat B2 moves from A to B, then B to D. A to B, the resultant velocity R3, then in B to D, the resultant velocity of R4. Velocity of B2 relative to Earth in two directions, from here A to B, from A to B, R2, then B to D, R4. This is R3, R3. Yeah, A to B, R3, then B to D, R4. R4. According to the theory of relative velocity, velocity of B2E is equal velocity of B2R plus velocity of R, E. As this B2E is equal in two directions, resultant velocity. B2 is equal R3 in this direction, R4 in this direction, BD direction is equal B2R, we know that is B is given, and BRE horizontal direction U. So here also we can draw one of the velocity triangle, but we want to draw in the same diagram, previous diagram. In this diagram, we want to draw the velocity triangle. Here also possible for two velocity triangle. We have two resultant R3 and R4. Therefore, here also for the boat B2, we can draw two velocity triangle. Okay, first start from U, this is the U, then B in this direction, because R3 is also horizontal direction. U here, then B, then resultant is R3 in this direction. Then we want to draw one more resultant R4. Therefore, U here, V. We don't know the direction, but resultant R4. Therefore, this is also one more velocity triangle. U here, V in this direction, therefore resultant R4 with horizontal 45 degree. This is also one of the velocity triangle. We want to find out now R4. You want to find out this R4. How to find out this R4? Produce this HO. Then from A, draw one of the perpendicular. That is the AN. Now this is 90 degree. This is also 45 degree. Vertically opposite angle. This already know this is a 45 degree. Therefore, AN is the AN. U, this one U, this is a 45. Therefore, AN is equal to U sine 45. Therefore, AN is equal to U over root 2. Sine 45, 1 over root 2. ON, the ON, U cos 45. The ON is equal to U over root 2. Now consider this triangle ANH. ANH. Right angle triangle is 90 degree. Using the Pythagoras theorem, HN is the HN. Square root of V squared minus this one AN. U sine 45 whole thing squared. Therefore, HN is equal V squared minus sine 45 1 over 2 U squared. Sine squared 45 U squared over 2. When we simplify, 2V squared minus U squared. Square root of 2V squared minus U squared over root 2. This is the HN. The HN this one. Our aim is we want to find out the R4. Therefore, this R4 is equal HN minus ON. This is the R4. From this is the HN. This is ON. Therefore, R4 is equal to HN minus ON. HN, we already find it this one. Square root of 2V squared minus U squared over root 2. Minus ON. This ON we already calculated U over root 2. So R4 is equal to this one. When we simplify further, R4 is equal 1 over root 2 out of the bracket. Therefore within bracket square root of 2V squared minus U squared minus U. This is the R4. And R2, how to find out this R2? This is the V, radius of the circle. This is U, therefore this is R2. Therefore R2 is equal to V minus U. And how to find out R3? You already know R3. This is the R3 from here to here. This is U. The radius B. Therefore, R3 is equal is U, here V U plus B. R3 is equal to U plus B or V plus U. Okay, now we find all the four velocity, resultant velocities relative to Earth. These are the resultant. R1 is equal 1 over 2 into within bracket square root of 2V squared minus U squared plus U. R4 is equal 1 over root 2 within bracket square root of 2v squared minus u squared minus u. R2 is equal v minus u. R3 is equal v plus u. And also I can show it to you in the moving diagram, which are R1, R2, R3, R4. You can find it out. This is the red color board. Board B1, R1 from here to here R1. From here to here R1. Then here to here R2. For the board B2, this one R3, A to B R3, from B to D R4. 4 resultant velocities. R1, R2, R3, R4. Now, we do some calculation. That is R2 minus R3. R2 minus R3. R2B minus U. R3B plus U. Therefore, R2 minus R3 is equal to B minus U minus B minus U. B and B cancel. Therefore, R2 minus R3 is equal minus 2U. Product of R2, R3. Product of R2 into R3. V minus U into V plus U. V minus U into V plus U. Difference of square. Therefore, V squared minus U squared. Then R1 minus R4. This is R1. This is R4. R1, this is R4. Therefore, R1 minus R4. 1 over root 2 into this term cancelled. Therefore, U minus into minus U plus U. 1 over root 2 into U plus U. Therefore, this is equal U plus U. 2U over root 2. Then product of R1 and R4. Product of R1 and R4. This one. You want to multiply R1 and R4. 1 over root 2 all in squared into this one. A plus B into A minus B is equal A squared minus B squared. Difference of square 4. Therefore, 2V square root of 2V squared minus U squared all in squared minus U squared. This is our product of R1, R4. When we simplify, 1 over 2, 1 over root 2 all things squared, 1 over 2 into, within bracket this one. Square root and square cancel, therefore 2V squared minus U squared. Here also minus U squared, therefore 2V squared minus 2U squared. 2 is a common factor. This 2 and this 2 cancel. Therefore, R1, R4 is equal V squared minus U squared. We see the diagram 1. The diagram ABCD. This AB and CD is equal A. This is also A because that is a square. AC and BD. So what is the AC and BD? This is the AC and BD. AC and BD are diagonal of a square of side A. Therefore, AC and BD is equal square root of A squared plus A squared. That is a root 2A. To the board B1, now consider the board B1, red color board. From here to here R1 velocity, then here R2 velocity. Let the time taken to reach the point D is T1. For the board, time is at T1. R4, R2. R1 and R2. Therefore, time taken to reach point D is a T1. Therefore, T1 is equal this AC over distance over velocity. This is AC over R1 and then CD over R2. AC over R1 plus CD over R2. AC we know root 2A over R1 plus CD we know A over R2. And for the board B2, now consider the board B2, green color board. A to B, in this distance, it moves with velocity R3, then B to D, move with velocity R4. And the time taken to reach point D is T2. For the board B2, total time is T2. Therefore, T2 is equal. So, T2 is equal this distance. What is this distance? AB over from here to here. AB over R3. Then from here to here. BD over R4. AB over R3 plus BD over R4. AB, A over R3 plus BD root 2A over R4. The T1, total time T1 for the board B1 and T2 is the time for the board B2 to reach the time. Now we want to consider the time difference T2 minus T1 and simplify and we will see what is happening. T2 minus T1. T2, A over R3 plus root 2A over R1, this one, and minus T1, for the T1 this, root 2A over R1 plus A over R2, root 2A over R1 plus A over R2. When we simplify this one, A into 1 over R3 minus 1 over R2, I consider this and this one. A over R3 minus this A over R2 and plus root 2A over R4 minus root 2A over R1. This one, A is the common factor out of the bracket. Therefore, this one when we simplify R2 minus R3 over R2 R3 plus root 2A into this one R1 minus R4 over R1 R4. We already calculated this one. Yeah, R2 minus R3 is equal minus 2U. R2 R3 is equal V squared minus U squared. R1 minus R4 is equal root 2U. R1 R4 is equal V squared minus U squared. Already calculated. Therefore, this result we apply here. Substitute to find out the T2 minus T1 time. So this is equal A into R2 minus R3 minus 2U, R2 R3 U squared minus U squared, this one, plus here root 2A into R1 minus R4 root 2U, here root 2U over R1 R4 U squared minus U squared. When we simplify further, LCM is a V squared minus U squared. Denominator V squared minus U squared. In numerator, this one minus 2AU plus root 2A into this root 2 2AU. Therefore, this is minus 2AU plus 2AU over V squared minus U squared. This is 0. That means time difference 0. Time taken to the board B1 minus the time taken to the board B2 is equal 0. That means two boards reach the point D at the same time. T2 minus T1 is equal to 0. Therefore, both B1 and B2 reach the point D at the same time.